Hello everybody. Today we will discuss problems from US Physics Olympiad 2009, first round, F equal MA. But before that, please subscribe to this channel, because in that case you will get all problems and all solutions for US Olympia from 2007 till nowadays. So for this contest there were 25 problems, and that were given 75 minutes. So first problem: a 0.3 kilogram apple falls from rest through a height of 40 centimeters onto a flat surface. Upon impact, the apple comes to the rest in 0.1 seconds, and 4 square centimeters of the apple comes into contact with the surface during the impact. What is the average pressure exerted on the apple during the impact? Ignore air resistance. So let's go straight. First, to find what is average pressure, we need to use formula pressure equal average force over area of this impact. So to find what is force, we need to use second Newton law. In our case, that will be this formula: F equal delta P over delta T, where is delta P, that's a change of momentum for time delta T. In our case, a change of momentum, that's a total momentum before collision, because final momentum is 0. So that will be just P over dt. Now, to find what is momentum before impact, we can use formula momentum equal mass multiplied by speed. And the speed we can find from formula that speed equals square root from 2gh. That's a simple energy conservation. So finally we have this formula for pressure. Or we can use numbers. That will be solution. So we need to convert all units to SI units. It means that kilograms, centimeters to meters. Final result will be this one, which is approximately 21,000 Pascal. So that's the solution. B, correct answer. Problems 2 and 3. The following information is used for questions 2 and 3. 3 blocks of identical mass are placed on a frictionless table as shown. The center block is at rest, whereas the other 2 blocks are moving directly towards it at identical speed v. The center block is initially closer to the left block than the right one. All motion takes place along a straight horizontal line. Second problem. Suppose that all collisions are instantaneous and perfectly elastic. After a long time, which of the following is true? A. Center block is moving to the left. B. Center block is moving to the right. C. Center block is at rest somewhere to the left of its initial position. D. Center block is at rest at its initial position. And E. The center block is at rest somewhere to the right of its initial position. Answer. Let's look what happened here. So first, because this left block is closer to center block, they will collide before this collide, right one collide. So after collision, they will exchange their velocity because they have the same mass, and this block, right block, will stop, and the center block will go to the right with a speed v. After that, it collides with the left block. They will exchange velocities, and now the right block going to the right and the center block going to the left, and it will meet this left block exactly in the same place when they first collide. But now this block, center block, is moving to the right, and the right block is in rest. So they will exchange velocity, and the left block will go to the left, but the center block will stop exactly in the same place as it was initially. So the correct answer is D. Next, problem 3. Suppose instead that all collisions are instantaneous and perfectly inelastic. After a long time, which of the following is true? A. The center block is moving to the left. B. The center block is moving to the right. C. The center block is at rest somewhere to the left of its initial position. D. The center block is at rest at its initial position. E. The center block is at rest somewhere to the right of its initial position. Solution. Because all collisions are perfectly inelastic and total momentum of whole system is 0, it means that after all collisions they will stop to move somewhere. It means that center block will not move. But what happened? First collision will be with the left block and center block. After this collision they start to move to the right, and after that they will collide with the right block somewhere to the right from center block initial position, and they will stop there. So it means that the correct answer is E. The center block is at rest somewhere to the right of its initial position.